Imagine packing your bags for the absolute ultimate cosmic vacation, only to find out the destination is actively trying to destroy you. In this explainer, we're simulating a completely doomed tour of our solar system to reveal just how inherently hostile our cosmic neighborhood really is. Forget those sci-fi movies where astronauts land easily on foreign worlds. We're going to dive right into the freezing, burning, crushing, and frankly terrifying reality of planetary physics.
Which brings us to a rather morbid question. Which planet would kill you the fastest? Let's dive into this by imagining a hypothetical scenario. Say you've been gifted an indestructible spaceship and a seemingly magic spacesuit. You're completely ready to explore. But as we'll soon see, even the absolute peak of human imagination and hypothetical technology might not save you from the universe's most violent extremes.
Here's the itinerary for our doomed road trip. First, the scorched inner worlds. Then, the deceptive red desert. After that, plunging into gas giants. And finally, the freezing ice giants. We're heading straight outward from the sun, mapping out our transition from the crushing rocky planets close to home all the way out to the freezing dark limits of the solar system.
All right, part 1, the scorched inner worlds, where aggressive heat is the name of the game. First stop, Mercury. And let me tell you, it's an absolute nightmare. You'd probably think being closest to the sun means it's just always boiling hot, right? Well, because Mercury only has a super thin exosphere instead of a real atmosphere to regulate temperatures, the swings are literally lethal. By day, you're getting blasted by almost 7 times the solar irradiance we get on Earth. You're baking at 430 degrees Celsius. But at night, it instantly plummets to a bone-chilling minus 180 degrees. To put that into perspective, the absolute best NASA spacesuits out there max out around 121 degrees and can only handle down to minus 157. Yeah, you're either instantly cooked or instantly frozen solid.
Now, you might be thinking, I'll just aim for the Terminator zone. That's that thin boundary area between day and night where temperatures are actually somewhat moderate. Good luck with that. Mercury is a tiny, rugged rock covered in massive cliffs and deep craters. Plus, with essentially zero air resistance to slow your indestructible spaceship down, hitting that tiny safe zone without a catastrophic high-speed crash is pretty much impossible. Moving about 40 million kilometers further out, we hit Venus. Now, the gravity here actually feels a lot like Earth's, which might give you a fleeting moment of, oh, this isn't so bad. Don't be fooled. The air is insanely thick, packed with so much carbon dioxide that just trying to move your arms would feel like wading through wet cement. And it doesn't end there. Eventually, that staggering 92 bars of atmospheric pressure is just going to completely crush your suit like a soda can. And hey, if the crushing pressure somehow doesn't get you, the descent absolutely will. As you drop through those deceptive, beautiful yellow clouds, you'll quickly realize they're actually made of highly corrosive sulfuric acid. We're talking acid strong enough to dissolve human lungs in a matter of seconds. By the time you actually hit the ground, only about 10% of the sun's light is even making it through that thick haze, leaving you in complete crushing darkness. Oh, and did I mention the surface sits at a blistering 450 degrees Celsius? Yeah, no thanks.
Moving right along to part 2, the deceptive red desert. Talk about a false sense of hope.
So, Mars gets a lot of hype as the most habitable planet in our neighborhood. And sure, a 20 degrees Celsius daytime stroll sounds pretty lovely, doesn't it? But guys, it is a massive trap. The atmosphere is incredibly thin and mostly carbon dioxide, with barely a trace of breathable oxygen. The second the sun sets, that comfortable spring day plummets to a freezing negative 13 degrees Celsius.
But the real kicker is this number, 50 times. Because that atmosphere is so unbelievably thin, radiation levels on Mars average around 24 to 30 rads. That is up to 50 times the radiation we get right here on Earth. Combine that invisible, lethal threat with totally unpredictable 100-kilometer-per-hour dust storms, you quickly realize why any visit requires a ridiculously shielded, absolutely airtight life support system.
All right, leaving solid ground behind, we enter part 3, plunging into gas giants. Welcome to the endless fall. Let's talk about the big guy, Jupiter. Just getting within 300,000 kilometers means facing a radiation belt that would fry a normal suit. But assuming our magic suit holds up, your horrifying descent begins. Jupiter's gravity is almost 2.5 times Earth's, pulling you down incredibly fast. You're smashing through frozen ammonia clouds, sitting at minus 150 degrees, getting absolutely battered by insane 482 km/h winds, just plunging deeper and deeper into some seriously bizarre layers of matter.
After hours of falling through pitch blackness, things get weird. You wouldn't just be falling anymore. You'd hit a layer of supercritical fluid. You would practically find yourself swimming through this incredibly dense alien substance before sinking even further into an inescapable trap, a massive, dense ocean of metallic hydrogen.
And why exactly is the hydrogen metallic down there? It's all because of this mind-bending number. The pressure near Jupiter's center is estimated to be 100 million times greater than Earth's atmospheric pressure at sea level. It's an astronomical, literally incomprehensible force just crushing inward from every possible direction. And deep down, these gas giants are violently hot. If you somehow miraculously survived the pressure and made it to Jupiter's core, you'd be slapped with temperatures around 24,000 degrees Celsius. Just for context, that is roughly 4.5 times hotter than the surface of the sun itself. Unbelievable, right? Over at Saturn, the nightmare actually starts before you even touch the atmosphere. First, you've got to play a deadly game of dodgeball through an obstacle course of 146 moons and massive icy debris rings. Once inside, yeah, you might see some absolutely stunning red and purple auras, but you're also getting violently thrown around by 1,800 kilometers per hour winds. And if you happen to aim for the North Pole, you drop straight into a localized storm so massive you could easily fit 2 entire Earths inside of it, all while freezing at minus 250 degrees Celsius before eventually sinking into crushing depths and a molten core.
Finally, Part 4. The Freezing Ice Giants. We've reached the darkest limits of our neighborhood.
First up out here is Uranus. Now, ice giant doesn't mean it's just a solid ball of ice. It just means it's mostly made of elements heavier than hydrogen and helium. This weird world spins entirely on its side, whipping through a single day in just 17 Earth hours. Once you make it past its own ring system and toxic gas, you are relentlessly bombarded by dense ice pellets in a bone-chilling environment. In fact, it easily earns the title of the coldest planet in our solar system, with temperatures dropping below minus 220 degrees Celsius. But here's where it gets wild. You'll find one of the most spectacular and lethal weather phenomena in the entire universe. On both Uranus and Neptune, the immense 100-bar pressure deep down actually breaks apart methane gas, crystallizing the carbon to create a literal rain of solid diamonds. Sounds gorgeous, doesn't it? Well, when driven by 900-kilometer-per-hour winds, this so-called beautiful diamond rain is essentially a high-speed sandblaster that would shred you to tiny pieces. Neptune is essentially Uranus's twin, sitting way out in the dark, a staggering 30 times further from the sun than Earth is. Out here, supersonic winds completely rule the skies. And because of the unbelievable pressure trapped inside, you get this massive contradiction. You absolutely freeze on the outside layers, only to be totally vaporized if you sink far enough to hit a core that burns at 7,000 degrees Celsius. Once again, hotter than the surface of the sun. When we take a step back and look at this planetary summary, it becomes painfully, glaringly obvious just how unique our home really is. From the crushing, acid-soaked oven of Venus, to the irradiated dust storms of Mars, the endless high-pressure depths of Jupiter, and the supersonic diamond rain of Neptune. Without Earth's perfectly balanced atmosphere and magnetic field, literally everywhere else in our neighborhood offers its own spectacular, unique flavor of instant destruction. Which leaves us with one final thought at the end of this explainer. Our solar system is a violent, extreme, and truly awe-inspiring place. But when we gaze up at the starry night sky, marveling at the sheer beauty of the cosmos, are we really just looking out the window from the only safe room in a deadly, cosmic haunted house? It's definitely something to think about the next time you step outside and take a deep breath of fresh air. Keep exploring, stay curious, and I'll catch you in the next explainer.